Hi and a very good day. So in this video session I will discuss on how can you perform box Jenkins method by using R programming, right? So when we're talking about box Jenkins method, okay, the first thing that occur to us is we want to model an ARIMA model. Okay, so now how can we perform such analysis by using R? Right? Okay, so for this purpose of explanation, I will discuss to you on what are the function that you need to use to perform several analysis that will be mentioned in this video. Okay, and I also provide you with the PDF, okay, with the PDF notes, so that you can fill in while listening my discussion today, right? So basically for this video session I will divide it into three parts by using textbook example, right? Which is okay, the first part is I will discuss on CPI example, and then the second part, okay, monthly road accident, and then the last part I will explain about palm oil production example and so on, right? Okay, so let's get started. Okay, so here these are actually library that you need to call it first before you proceed with the analysis, right? Okay, so if your R's doesn't have this library, okay, you can install the packages, right? Refer to my previous notes on how to install the packages, and after install the packages, don't forget to call the library. If not, R will not proceed with the example here. Okay, so let's take a look at my example. Right, so here in box Jenkins methodology, we call it as methodology because of what? We divide it into stages. Okay, we have model identification stage, we have model estimation and validation stage, and then after we estimate and validate the best model for ARIMA, okay, we apply the model to forecast the value, right? So and for your information, this particular method is not stop at there. Okay, we need to monitor our model even after we choose our best model, okay, based on this box Jenkins methodology, right? So I explain to you based on examples. Okay, this particular data set I will provide it to you. Make sure that you download. After you download, okay, I will give you both the Excel format and the CSV format, right? And make sure that you save the data into your directory. Means behind your directory is, okay, suppose that I use getwd to get my directory location. So this is my directory location, user asmi document time series node. So you open your files, okay, document, and then okay, try to look at okay, time series node, and this is my directory. Okay, as example here, I already save my data set into my directory. Okay, accident casualty, CPI annual, and palm oil production, and so on. Okay, make sure that you save it into your directory, and then you can proceed with calling the or we read the data set into R. Okay, this is the way. Okay, one more alternative, you can use the RStudio tab here, file, import data set, and then you can choose if you choose from Excel, right? As we can see here, you can import, browse, okay, Excel, open, okay, make sure that it is an Excel file right here. Okay, and then you will get the preview of your data. and then you just click import. Okay, what are your data set name? This is the name, accident casualty. You can change, okay, according to your preference, right? Okay, I will not continue since that I already called the data set. Okay, this is my data set. As example here, I use CPI, and then my data set name CPI annual, right? After that, I just check the structure so that I want to make sure I'll read my data correctly. Okay, and now you are ready to do some analysis. Okay, before that, for model identification, it is important for us to plot the original series first. Okay, to plot the original series, especially time series data set, in R, you have to define the object as time series first. Okay, so what we do, we use this TS function. Okay, so this TS function actually we define variables. Okay, variable as example here, our variables is CPI. Okay, so I call the variable CPI by using the dollar sign here, and then this CPI annual is actually the our name, our data set name here, CPI annual. Okay, so I call this particular variable, I change the variable into time series, which is TS function, and I define the start and end period of our series, and then I use frequency equals to 1 to represent the yearly data set. Alright, and then we plot the original series. As we can see here, okay, this is actually I add some argument here to customize our to make it more interesting to look at. Okay, I actually add some you can experimenting as you do your own customization, okay, by change this argument. Okay, the COL here is for the color, Y lab is for label, Y lab, the main is the title, and then the X lab is the X label. Type O, we want to plot this particular dotted, and then PCH20 is the pattern of our plot. Okay, and then as we can see here, based on the original series, there is actually significant upward trend, okay, from 1972 until 1997. Okay, so this is this is the thing that you need to find when you the characteristic of your data set that you need to find when you plot the original series, whether our original series has trend or seasonal, or trend and seasonal. Okay, and based on this, since that our original series has trend, okay, remember in our previous note, when there are actually a linear trend in our series is not stationary. Okay, so this is the first sign. So what's next? Okay, for box Jenkins methodology, you need to perform the ACF and PACF for the original series first. Okay, so as we can see here, based on the original series, okay, you can see the pattern of slowly decaying pattern when the number of lag is increasing for ACF, while for PACF you will see one significant spike here. Okay, how can you interpret this particular pattern? Okay, slowly decaying ACF means that the data is not stationary, while for PACF, one significant spike might give us the idea of when we perform the first difference, our original series might become stationary. Alright, and that's why in the next step, okay, we can perform the difference, the ACF and PACF for the different series by adding different function here. Okay, this different function here is actually to perform the ACF and PACF for first difference. Okay, as example here we use CPI data. right? So based on this ACF and PACF, even though that there is actually still decaying pattern, but it is much faster rather than the first uh, okay, the original series. This is much faster, and it is actually dying out. Okay, the decaying is dying out at lag 5, as I mentioned here, right? So this is a signal where our data sets here is already stationary, but it is only based on ACF and PACF pattern. It is actually, you can confirm it by performing stationary testing tests such as ADF test to reconfirm your finding whether our series is stationary or not. Okay, so here remember to apply the box Jenkins method, we have to ensure our data series is stationary first, right? So based on this, since that the data series only stationary after we perform the first difference, okay, it means that now the order of the order of D, okay, remember our previous notes, okay, D is the small capital D, because we talking about okay, ARIMA model without seasonal component, just trend. Okay, so the small capital D is equals to 1 for this particular example, right? And then next we proceed with model validation and estimation. Right, so we try to figure out what are the best model that represent our series here. Okay, what are the ARIMA model that most suitable for our series? Okay, so based on this explanation, okay, you can refer to guideline in page 271 in your textbook, right? When your ACF is decaying pattern, while PACF give us several significant spike. Significant spike here means that any spike that greater than the standard error band here. Okay, this is what we call it as significant spike. Okay, so here okay, for the purpose of example, okay, following the guideline in page 271, we say that the most suitable model is ARIMA 110. Okay, we take the most significant spike for PACF. Okay, PACF is for AR. Okay, while ACF to determine the order of MA, the Q order. MA, Q, AR, P. So for PACF, we determine the P order, while for ACF, we determine the M order. See, okay, so based on this pattern, we say that we identify the suitable model to be ARIMA 110, right? And to obtain more conclusive evidence, we list several alternatives, and we will choose based on textbook example. Okay, when modeling ARIMA model, okay, the concept of parsimony is very important. Okay, we will try to model the ARIMA model that give us the simplest form. Okay, as long as after that, when we perform the model validation and estimation, the test and the requirement is being fulfilled. Okay, as example, the residual is white noise. Okay, and so on. Okay, so let's take a look at how we model the ARIMA model by using R. Okay, the function that we will use is ARIMA. Okay, ARIMA. Okay, and we apply it towards the original series. Because of what? We let the R to different it to us. Okay, this order is okay according to PDQ. Okay, the small capital P equals to 3, which is for AR. Okay, this is example if you want to perform ARIMA 313. So AR here, the P order is equals to 3, the D equals to 1, the Q equals to 3. So how do we write in R to model this particular model? Okay, you use ARIMA function, the original series CPI annual.ts. Okay, .ts here means that it means that this particular series that we already define it as a time series object. Okay, so here ARIMA CPI annual.ts, and we give the order, okay, accordingly 313, 310, okay, 111 and 110. Okay, so how can we determine the best model? Okay, for this particular box Jenkins, this particular stage, model validation estimation, we will use the model that produce the lowest AIC, the information criterion. Okay, you can read the formulation of AIC in your textbook. Okay, there is actually explanation on the information criterion, okay, based on this output. ARIMA, the summary of the model will give us the AIC value. Okay, as we can see here, this is the coefficient. Okay, this is the AR is the phi, while the MA is the theta. Okay, the phi 1, the phi 2, the phi 3, theta 1, theta 2, theta 3. Refer back in your previous note. Okay, so based on this particular model, we will use the smallest AIC, which is, for this example, the smallest AIC is actually model 2. Model 4. Okay, this is the smallest AIC, 133.26. Okay, 133.26, while the others have 135, 136 and so on. Okay, so the best model is model 4, which is ARIMA 110. Okay, and then we further the investigation of our residual, whether our residual are white noise or not. Okay, so as we can see here, model 4. Okay, I choose model 4. Okay, according to your fitted name here. Okay, model 4 ARIMA. So I use model 4, and then I test the residuals. Okay, to call the residual, we use $ residual to test whether the residual are white noise or not. And then the test that we will perform is Leung-Bock test. Okay, which is, okay, the function is Bock test, and then the type is Leung-Bock. Okay, this is the way on how you can perform. Okay, here make sure that you know how to interpret the Leung-Bock test. Okay, if p value is greater than 0.05, means that we accept the null hypothesis of white noise. Okay, so for this model to be a good fit model, we need the p value to be greater than 0.05. Right, so that's the end of stage 2, model estimation and validation. Alright, next we proceed with model application. Okay, after we choose the best model upon these several alternatives, now we can produce the forecast value. Okay, so how can we produce the forecast value? Okay, now I need you to to take take note here. Okay, we use predict function. Okay, predict. Okay, this predict function give the model 4. Okay, model 4 here is based on these names. Okay, model 4, and then how many step ahead. Okay, suppose that we want to forecast from 1998 until 2002. Okay, so the model, the step ahead is n ahead equals to 5. Okay, this is actually on how can you forecast the value. Okay, model this is the name. Okay, this is the function. Okay, now we will try to to plot both original series and the forecast value. So how can we do that? We use ts dot function. Okay, this is the original series and this is the predicted value. Okay, so for further investigation, we even can plot plot the forecast value for 1998 until 2002. Okay, so this is the point estimate, while this is actually the confident this is actually confident estimation for our forecast value for this particular example. Right? Okay, so I hope that you understand on how can we perform box Jenkins method by using R. Right? I think for the first part of video, I end it here. Thank you for listening. If you have any question, just ask me in the reply comment below. Right? So thank you guys. See you. Bye.